Okay, one of the many things that we want to talk about is what is the percent composition of elements in a compound. So that's what this podcast is about, and hopefully before you're watching this podcast you've done the little lab snack attack, and if you've done that then you probably already have a pretty good idea of what percent composition is. Okay, the textbooky definition of percent composition is this. It's the percent of each element that makes up a compound. Okay? Now, we talk about this when we do percent composition as we are talking about percent by mass. There are other percents that you could do. You could do percent by volume or things like that, but we are just going to deal with percent by mass. Now, the fairly simple, straightforward equation for this is if I want to find out the percent of an element, I take the mass of the element and I divide it by the total mass of the compound, and then I multiply it by 100. So really, finding percent composition is exactly like finding your grade. Okay? If I'm looking at my grade and I got 8 points out of 10, well, that 8 out of 10 is an 80%. That's my percent composition. Okay? So really, finding percent composition is not really a difficult thing. Okay? So we're just going to do one example here where we're going to find the percent of each element in the compound aluminum sulfate. And I will not get away from making you write formulas. So obviously, one of the tricks is going to be if you don't write the correct formula, then you are not going to get the correct percent compositions. So I have aluminum that has a +3 charge, and sulfate was one of the 5 that I told you to memorize a long time ago, and that's got a -2 charge. So the correct formula for aluminum sulfate is Al2SO4 3. Okay, so that's aluminum sulfate. Now, if I want to find the percent composition of this compound, okay, there's my equation that I need to use. One of the first things I need to do is find the total mass. Okay, well, that's what you did with the last assignment. You found the total mass of the compound. So we're going to go through here, and I have aluminum, and I have 2 aluminums that each have a mass of 26.9 grams per mole. And those numbers are found again off the periodic table. And then I have how many sulfurs? And hopefully you are saying that you have 3 sulfurs. And each sulfur, looking at the periodic table, has a mass of 32.1 grams per mole. And then how many oxygens do I have? Okay, hopefully you're saying that you have 12 oxygens, and each oxygen is 16 grams per mole. Okay, so I want to find 2 times 26, that's 53.8. 3 times 32.1 is 96.3. And the last one is 192. Okay, and all of these are grams per mole still. That hasn't really gone away. Okay, so I'm going to take and I'm going to add all 3 of those numbers up. So my total molar mass is 342.1 grams per mole. So that's my total molar mass. So now, if I want to find the percent of each element, and that's the key word is I want each element, okay, what I'm going to do is I'm going to go back to this equation, and I'm going to take the mass of the particular element divided by the total mass of the compound. Okay? So, I'm going to go down to this point. Let's find the percent of aluminum. Okay? Well, the mass of aluminum is 53.8 grams. Okay, so I'm going to take 53.8 grams per mole, and I'm going to divide that by my total mass, which is 342.1 grams per mole. Now, I'm never going to show this again, and I'm not even going to write these in the future. Grams per mole cancels out. Okay? So in the future, you're not even going to have to worry about those. And then we're going to multiply this by 100. And so when you do that, go ahead and do that in your calculator. That's going to equal 15.7%. So that means that in this compound of aluminum sulfate, 15% of it is aluminum. Okay? So let's find the percent of sulfur. Okay? The percent of sulfur is going to equal the mass of sulfur that I have, which is 96.3. And notice I'm not going to write the units anymore. Divided by my total mass, 342.1 times 100. And that's going to equal 28.1%. So 28.1% is sulfur. And then my last one is I want to find the percent of oxygen. And now it kind of looks like oxygen has the largest mass here, so I bet it has the largest percent. Okay, so I'm going to take the mass of oxygen, which is now 192. So I'm going to take 192 divided by my total, 342.1 times 100. And that is going to equal 56.2%. And that's percent of oxygen. Now, theoretically, these percents should all add up to be equal to what? 100%. And so if you add these up, that's 0 and 0, 0, 1. So that does add up to be equal to our 100%. Now, when you do this, due to rounding and things like that, every once in a while, you might get something at 99.9% or even smaller than that. Close enough, okay? It's 100%. So that's percent composition. I'm going to do one more example. Oops, don't want you to see that yet. We're going to do one more example, and I do want you just to look at this particular example. I know you probably have this concept, but I'm going to talk about a compound called copper 2 sulfate. Oops. Copper 2 sulfate pentahydrate. Now, that's a name that you've seen before, okay, as far as the pentahydrate, but I've kind of had you ignore it. Well, it's not really that hard to add that to a formula, okay? First of all, we're going to write the formula for copper 2 sulfate. So at least go ahead and do this. Write the formula of copper 2 sulfate. Don't even worry about the pentahydrate. And you should be writing CuSO4. Okay? Now, hydrate. When you hydrate something, what does that mean? Okay, and what you should be saying is, well, hydrate, that means drinking water or getting water. Hydrate is just water. Well, what's penta? Penta is 5. So 5 hydrates, 5 waters. Okay? So what this is there are 5 water molecules that are added on to this particular compound. And for whatever reason, they use a dot, and I've never bothered to care why. Okay? And they put 5H2O. So that's copper sulfate pentahydrate. Now, what I want to do is I want you to find the percent of H2O in this compound? Well, again, what you would need to do is find the total molar mass of the whole compound. Okay, so we're going to have to separate this out and figure out the mass of copper. So copper, there's one copper atom at 63.5, and I'm going to drop the grams per mole. There's a sulfur, there's one sulfur at 32 grams per mole. Okay, and right here, there's 4 oxygens at 16 grams per mole. And then hydrogens, how many hydrogens have I got? And there's 10 of those at 1 gram per mole. And then, with this 5 and this oxygen, I have another 5 oxygens at 16 grams per mole. Now, if you see this, okay, you can actually take these and combine them into one, and that's fine. I just separated them out so you can see it. So, mass-wise, I have 63.5, I have 32, I have 64, I have 10, and 5 times 16 is 80. Okay, so I can add all these up, and I can find my total molar mass is 249.5, and all of this was still grams per mole. I just got lazy. Okay, now what I wanted to find out was what is the percent of water. If you remember, that was my original thing. And so what you need to do is find out what is the mass of just the water. Well, just the water was the 10 hydrogens at 1 apiece, so that's 10, and it was the oxygens, there are 5 of those at 16, so that was 80. So the mass of the water is just 90 grams per mole. Okay, so this right here, okay, was actually already done for us right there. Okay, but if I want to find the percent of water, the percent of H2O in this compound would be 90 divided by 249.5 times 100. Now, where did that 90 come from again? Okay, the 90 is just the mass of just this part, which we calculated right there. That's where that 90 came from. And so the percent of water in this particular compound is 36%. And that's how you do percent composition. Now, your assignment then should be the percent composition worksheet.